And it's that time again. Welcome to CramTime. Welcome to another video. Today, we'll be discussing the combining of like terms. This is CramTime, so feel free to set this video to 1.5 or 2 times speed. That being said, let's hop right into it. Here's a quick need-to-know basis kind of overview of what a like term is. So I like to think of like terms in two categories. Like terms can be constants. So a constant with another constant is a like term. So in this kind of matching sequence I have here, if you were going to be combining like terms, you'd be combining the constant 7 with the constant 2. Now, the other aspect of combining like terms, a like term is when you're comparing variables that have the same degree, regardless of the coefficient that goes with it. So here, for example, I have x to the power of 2, x squared, and that is my term, that x squared. So if I'm combining like terms, my like term will be any other term, no matter the coefficient, with an x squared. So I would be combining this 2x squared with the 3x squared. And of course that leaves the logic of the x, which is actually x to the power of 1, would be combined with its like term, which is 101, which is the coefficient, not important again, times x to the power of 1. So that is your like term. This concept is honestly super simple, so let's just fly through some examples. So we have your traditional combining of like terms, where here I have 4 plus 7x plus 3x squared plus 2, and you can see that I have two constants here, so frankly I can just make it 3x squared plus 7x plus 6, and that just simplifies I guess the formatting and the length of the expression that I was originally given. Now, not only can these like terms be combined, but they can be used to cancel things out. So say, for example, I have 3x plus 7 plus 4x squared minus 2x minus x. Let's just make that minus 3x. Not only can I combine like terms in like the previous example where they combined my 3x and my minus 3x, if I'm combining like terms, the x to the power of the 1 and the x to the power of 1, if I combine them, 3x and negative 3x, the way the coefficients combine, they simply cancel each other out, so I'm left with 4x squared plus 7. That's the essentials you need to know. You can click off this video and go to the next video in the playlist. If you're studying, if you have some more time, we can go through some more complicated and fun problems. I almost forgot that you can combine like terms from opposite sides of the equation. It's essentially simplification, but it is still technically combining like terms. So here we have two different variables, the x and the y, something that you'll see very commonly when we move on to graphing and that sort of thing. So I'm just combining like terms, just as x to the 1 and x to the 1 are like terms no matter the coefficient. Y to the 1 and y to the 1 are like terms that can be combined, so I can go ahead and subtract the y from both sides. So and then I can also, I want to move my x's and my constants over to the right side of the equation and keep my y on the left side. It's again something that you will just grow a habit of doing as you do more and more math. It makes sense, trust me. You can subtract an x from here and subtract an x from here. Then you can add a 7, and you get y is equal to 6x plus 9. And you're going to do this quite commonly when you're converting from different formats into a slope-intercept equation. So I guess this is where we're going to stop the video for today. Keep it short, sweet, simple. These are the basics that you need to know to go out and do well on that first test. Alright guys, this concludes the video on combining like terms. If this video is beneficial to you, feel free to go through the other videos on this playlist. Also, we'd really appreciate it if you could hit that like button, subscribe to the channel, and leave some comments down below as to videos you want me to create later on. Alright, have a good day, stay safe.